everyone, welcome back. I'm Dr. Abdul Ghader, emergency medicine specialist. I'm board certified in emergency medicine. I am RDMS certified. I've been working in emergency department for over 13 years now, including 7 years as assistant professor. Now, let me tell you, ultrasound is hands down my favorite tool in emergency room. Honestly, I scan almost every single patient. It helps me quickly rule out life-threatening condition, save time, make faster diagnosis, and start treatment right away. It becomes like a second nature for me. So today, we're going to talk about one of the most important foundation in point of view ultrasound. It is the basics. Whether you are just starting out or brushing up, this stuff is essential. Let's dive in. Welcome to POCUS Pulse by EMSR Academy. I'm really excited that you're here. Today's topic is about ultrasound physics, and we will make it easy. We'll be covering graphs, variables, units, and conversions. Trust me, it sounds more complicated than it is. Let's make it very super simple, super useful, and kind of fun. Ready? Let's go. Okay, here what we are going to talk about today. How to read graphs and actually understand what they are mean in ultrasound. What it means when variables are directly or inversely related, and how to work with scientific notation and power of 10. And finally, how to convert units quickly without pulling out your hair. Let's break all this down together. Okay guys, let's talk about the graphs. Graphs, they are everywhere in ultrasound. You can find them in M-mode, Doppler, B-mode, and etc. But don't worry. All we need to know about the graphs is 1. The x-axis. Run side to side. That's your timeline or distance. And the second one is y-axis, goes up and down. So we can find changes in things like amplitude and velocity. So graphs are just like a tools to tell you a story. It is a tools to communicate with your machine. So you're learning the language. Okay, so we talked about the graphs, and right now you know how we can communicate with ultrasound machine using the graphs as an ultrasound's language. Let's talk about relationship. In ultrasound, there is some variables, and we need to know these variables, how they are related to each other. So this type of relationship, it is between variables, not the people. We have two main relationships in the ultrasound, unrelated and related. When you say something is unrelated, means there is no connection between them. For example, hair color and your size. There is no connection between your hair color and your size. The second one is related. When you're saying that something they are related to each other, means there is a connection between them. But how? It's not clear for us sometimes, like flossing and dental health. But don't worry, we just need to know if there is a connection or not, and what kind of. Okay, so right now you know some variables are related, and some variable they are unrelated to each other. When we have two variables that they have direct relationship to each other, means when one thing goes up, the other goes up too. Like your age and your height when you are a kid. When you are a kid and you are growing, so your height also will increase. There is a direct relationship between your age and your height. Or how practicing more usually means you get better. On a graph, this direct relationship looks like a line going uphill. Okay, so we talked about the direct relationship. When some variable goes up, the other will go up. But we have opposite relationship, inverse relationships. When one variable goes up, the other goes down. Like for example, the hotter it gets, the fewer clothes you need. The more you party, the worse your grades probably. And the graph, it's like that. It slopes downhill from left to the right. Okay, so we talked about direct relationship, inverse relationship. Another type of relationship is reciprocal relationship. Reciprocal relationship is special. They are inverse, but with a twist. If you multiply two variables, you always get one. in ultrasound, this is a huge, for example, frequency by period. Always it is 1. So we will get 1. So if one goes up, the other must go down to keep the balance. Okay, time for quiz, time for practice. Let's test your thinking. Just pause and comment. So it is some tests just to help you to be ready for ARDMS exam, for SPI exams. So tell me if these variables are direct, inverse, or unrelated to each other. Cholesterol and lifespan, calories intake and your weight, IQ and your shoe size. Pause and comment the answer. We will discuss to each other. Okay, so let's talk about the powers of 10 and scientific notation. I'm sure everyone knows about that one. It's a very easy topic, and I just wanted to have a quick review and say it's a smart way to move from decimal, and in ultrasound we use these all the time. Instead of, for example, writing 1000, we can just easily write the third power of powers of 10, or instead of writing point 0000, for example, 6 zeros and 1, we can just easily write -6 powers of 10, and it is just smart way to move from decimal, and is practical in ultrasound, and we always use this way. And this one, it is about metric system basics, and I think it's easy topic also. Knows about that one, just have a quick review. So we have giga, like a billion, so it shows by J, and mega or M, a million, kilo or K, a thousands, and also on the small size we have milli, micro, nano, teeny, tiny. So we in ultrasound we usually use megahertz and microseconds in ultrasound all the time, and it is the practical things that we use in ultrasound. It's more we use megahertz and microseconds. In ultrasound, we have some complementary units, and these units always show up together, like megahertz and microseconds, or kilohertz or milliseconds. So one measure frequency, for example, megahertz, the hertz measure frequency. When you say megahertz, so it is a measurement for frequency, and microseconds, so we measure time. So kilohertz measures frequency, and milliseconds measures time. So they are like ultrasound besties. We'll see them paired up all the time. Okay, so let's talk about the unit conversation. Unit conversations are very important in ultrasound. You know why? For example, if you say it is 10, so that's 10 what? Centimeter, minis, cupcakes, it is totally meaningless. So in ultrasound, it's very important to always double check our units. Usually in ultrasound, we deal with centimeter for depth, centimeter squared for area, and cubic centimeter for volume. So in conversion, when say increase by factor means multiply, and when say decrease by factor means divide. So do this conversion, and please comment. Convert 12 inches to centimeters, and also convert $5 to DMS, and comment please. Right now, you may asking yourself, what is the practical aspect of these theoretical things? So, and why we should care about them. These relationships and units usually show up all the time during the ultrasound. For example, in Doppler, always we have frequency and velocity. In the measurements, we have depth in centimeter, and imaging also period and frequency are what make your pictures work. So you need to know about them, because this stuff is actually powerful and help us to understand the images. In the next episodes, we will talk more about the frequency, period, velocity, and frequency. And here we just wanted to mention what is the application of this theoretical in basic ultrasound physics to understand how we can use them in our ultrasound practice. Thank you for being with me till now. Let's wrap up this. Graphs help us to see the relationship, to understand the ultrasound languages, to know how we need to communicate with the ultrasound machine. Direct and inverse help us to predict the behavior, the outcome, how the variables they have relationship to each other. And the scientific notation help us simplify crazy big numbers or crazy small numbers. And conversions, they keep us from messing up. For sure, you've got all these. Any question? Please drop them in the comment. I love hearing how you understand these things, or even better, tell me how you remember this stuff. Thank you for hanging out with me today, guys. If you found this helpful, please like the video, hit the subscribe, and share it with someone learning ultrasound. And please don't miss the next episode. We're going deeper into the ultrasound physics. It was just a very, very basic in ultrasound. Just I don't want to skip it, and because it is very important to understand the basic, and then we will go deeper in the ultrasound physics in a very, very funny and clear way. See you there.
Emergency minds, sharp as a blade in the darkest of hours, no time to evade. Point of care vision.